So part 2, we're looking at a different approach to understanding consumer behaviour. It still falls within what we call neoclassical theory, but it's an entirely different approach. The basic goals of our consumer are the same, except now we express it differently because, in a sense, we're abandoning the old idea of utility as a measurable quantity of happiness. And we're instead moving towards the idea of consumers simply having preferences, ordered preferences in particular. So that's why we call this ordinal preference analysis. So this is going to be composed of two parts. Really, the purpose of this entire theoretical apparatus that we're going to look at is to be able to theoretically construct a demand curve. And you'll remember the demand curve is where a downward sloping line showing an inverse or negative relationship between price and the quantity demanded. If we think about the concept of demand, we're saying that it's the quantities that a consumer is willing and able to purchase at various prices. So first, we've got this willing and able. So let's look at the able part first, which is about a budget. You're able to purchase something if you can afford it. So we want to be able to construct something we're going to call a budget line. And what's that? This is a line on a Cartesian plane. A Cartesian plane is just a two-dimensional plane. You've got an x-axis and a y-axis. Anyway, a line on a Cartesian plane showing all the combinations of the maximum affordable quantities of two types of goods given a consumer's budget, that they've got a certain amount of money to spend, and the prices of the goods that they have to pay for them. And we can construct a budget line in this way. First, we'll just get the general idea. Let's say you've got a certain amount of money at your disposal and you decided to spend all of it on good Y. Let's say the maximum number of good Y you can purchase is 4 units. If you said, I'll not spend all of my money on Y, I'll spend most of it on Y and a bit of it on X, then I could afford this combination. They said, no, I think I'll get a bit more X, which means I can afford less Y. So I'd have this combination. And I can also afford this combination, and this combination, and this combination. This is all assuming I'm spending all of my money. If we join the dots, voila, we've got a budget line. So everything under the line is affordable. Our consumer can afford any combination under and up to that boundary line. But anything beyond the boundary line, anything beyond the budget line, our consumer can't afford. They simply don't have enough money given the prices of the goods that they might want to purchase. So this is the basic concept of a budget line. It looks like a demand curve, but it is not a demand curve. Now let's go on to the willing part of the quantity that a consumer is willing and able to purchase at a given price. So how do we represent these wants or preferences? We're going to use something called an indifference curve. An indifference curve is a line on a Cartesian plane showing all the combinations of two goods that are equally preferable to a buyer. They are indifferent between these various combinations because they make the consumer, any of these combinations make the consumer equally happy. So they equally prefer them. So as it says there. So let's try and represent this idea. Let's say all of these combinations that I'm going to show you of X and Y are equally preferred in the consumer's mind. They like this combination, but they like this combination just as much and they like this combination just as much as the other two, and they like this combination just as much as the previous three, and blah 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 blah. Since they like each of them equally, they're all equally preferred, our consumer is actually indifferent between them. If they have to choose one of these combinations, they don't care which one, because each one makes them just as happy. So let's join those dots and we get this indifference curve. We call it an indifference curve because it's showing for all these combinations our consumer is indifferent between them. Now you'll note there that the slope of this indifference curve diminishes. So we're moving from this point to this point, and you can see that slope is getting flatter and flatter. The slope diminishes. The slope of the curve is called the marginal rate of substitution. Why marginal? Well, marginal just means small change here, additional or extra. So it's a small change, and it's the rate of substitution. So think of it this way. If we move from this point here to this point here, they can substitute an extra unit of x for some amount of y and remain equally happy. If they want to substitute more x with some y, it will be a smaller amount of y. And they substitute some more x for some even smaller amount of y. And in the way that I've drawn this indifference curve, that marginal rate of substitution is diminishing. Okay? The amount of x given up in order to gain one more y gets smaller and smaller and smaller and smaller. Alright, that's just telling us about a particular property of this particular indifference curve. Most of the time when you see indifference curves, they will have this convex shape, but they don't necessarily have to. The marginal rate of substitution might not be diminishing. It depends on the two kinds of goods that you're looking at, that you put on the x and the y axis. But most of the time, for most goods that are put on the x and y axis, you have this marginal rate of substitution that's diminishing. So you get an indifference curve that looks like this. Alright, next. Another thing to say about this is that there's not just one indifference curve, right? There can be more than one. In fact, when we see indifference curves, and a bunch of them together, it's called an indifference map. And the indifference curves that we see are really samples of the gazillions of indifference curves which are all here in this Cartesian plane. So, for example, there could be another one here. Let's take a point on that second indifference curve. Now what's interesting about this is, and I use the term interesting loosely, what's interesting about this is that if we take this point on this higher indifference curve, we can see that the person would be consuming more y and more x than they would be if they were on this at this point on this lower indifference curve. Now, since we're assuming that our consumers like both of these products, they would like more of both of them. They would prefer more of both. And since this higher indifference curve, at this point at least, clearly indicates that they are getting more x and more y than on this lower indifference curve here, and also since every point on this higher indifference curve is equally preferred, it must be the case that every point on this higher indifference curve is preferred to every point on this lower indifference curve. And similarly, on this indifference curve, if we select a particular point, we can see you get more of both x and y again. So, and since every point on this higher indifference curve is equally preferred, but this point is preferred to this lower point, it must be the case that every point on this higher indifference curve is preferred to every point on this lower indifference curve, which is preferred to every point on this even lower indifference curve, and so on. Basically, what we can say when we've got indifference curves like this and we're talking about X and Y are goods, that is, things that people like to have more of, the further you move away from the origin point, 0, the more preferred the combinations are. So our consumer would like to get to the quote-unquote highest indifference curve they can, or the indifference curve furthest away from the origin they can. Most of the time. There are obviously provisos there, but we won't worry about that. Now, why are we using these indifference curves instead of marginal utility? The reason why we move away from marginal utility, which is associated with cardinal analysis, and use indifference curves instead, is because we haven't been able to actually observe or measure utility in the mind. We can't just lop off the top of your head and start seeing the happiness inside, or measuring the happiness itself. If we say, well, how much more happiness do you get from seeing a friend than you do from eating an apple? One might be able to say, I get more happiness from seeing a friend than eating the apple, but I don't want to know that. I want to know how much more happiness exactly. I want it to be a measurable amount, in the same way as you would measure the length of a table or the weight of a bowling ball. I want a precise quantity. And when you ask people that, it's no one can give a straight answer, because it's the nature of happiness doesn't seem to have this quantitative property to it. Anyway, what we can do instead is we can observe and understand a buyer's preferences via their statements and decisions. If a person says, I like apples more than oranges, I can understand what they mean. Given a free choice, they'll choose the apples over the oranges. But if they say, I get 15 utils of happiness from an apple, and I get 10 utils of happiness from an orange, I'm not 100% sure what this 15, how much is that 15 utils? What does that mean exactly? Alright, so due to this problem of utility not being a measurable thing, we move on to using preferences instead. Now let's look at a particular example. So let's say Jenny has a snack budget of $12 a day. She's only interested in smoothies and nuts. The price of a bag of nuts is $3. The price of a smoothie is $2. And so now let's try and graph Jenny's budget line with the quantity of smoothies on the x-axis. How are we going to work this out? Well, it's actually easier than you might think. All we have to do is think to ourselves, if Jenny spent her entire budget on just bags of nuts, how many could she buy? Well, that's easy to work out. It's just the budget divided by the price of the bags of nuts. So I here is standing for her budget or income. So $12 budget divided by $3 for the bag of nuts, and we get 4 bags. Then we ask the alternative. What if, on the other hand, she had spent all of her budget on just smoothies? Well, then it's the budget that's available divided by the price of the smoothies, which is $2 each. So that's a total of 6 smoothies. These are the two extremes. All we then have to do is join the dots with a line, and voila, we've got the budget line. Simple. It's that easy. So income, or the budget, over the price of nuts gives us the maximum of 4 nuts. Income over the price of smoothies gives us the 6 smoothies. What's the slope of Jenny's budget line? Well, that's easy. The slope is just the rise over the run. And we've got, it's a giant triangle, so we've got the rise here up to 4, and the run is 6. So it's 4/6, or 2/3. We should say that that's negative 2/3, shouldn't we? Because this is a downward sloping budget line. So it's a negative 2/3. What determines that slope? Alright, so now we've got to get a little bit tricky. So remember, we've got rise over run. Let's use these ratios. So let's just put them like this. So we've got the rise over the run. Now let's take this thing here and let's rearrange it a bit. Instead of this divided by this, we could also express it as this multiplied by the reciprocal of this. It's the same thing. Okay? We're just rearranging it, and that's handy because when we rearrange it in this way, we can easily see, we can cancel out the i's, we can cancel out the budgets. So we can simplify it to this: the price of smoothies over the price of nuts. Remember, this is the slope. All we're doing is calculating the slope, or representing the slope, right? And we're now representing the slope with this here, this being a price ratio. Okay, the slope of the budget line is determined by the price of the good on the x-axis over the price of the good on the y-axis, by this price ratio. If one of or both of the prices were to change, then it's possible that the slope of the budget line will change as well. So we say it's this price ratio that determines the slope. And just to double check, you could say, alright, well, let me just check that that's the case. Price of Snickers over the price of a bag of nuts. Remember what the slope was before? Voila. It's the same. But remember, our slope is really a negative, so it's negative 2/3. Okie doke. Happy with that? Good. So, what combination of the nuts and the smoothies will a rational Jenny choose? So we know how much, these are all the possible combinations which Jenny can afford. What's the combination she will actually choose though? Which one does she want the most? Well, here's an indifference curve representing a whole bunch of different combinations of smoothies and bags of nuts that Jenny might like. She could spend all of her budget, that is, be on the budget line, with this combination. She could equally be on the budget line with this combination down here. She would be equally happy with both, but could she, remember, get to a higher indifference curve, a more preferred combination to any of the combinations on this line? Of course she could. She could move up to this indifference curve. She could get this combination. She could spend all of her money and get this combination. She could spend all of her budget and get this combination. She'd be equally happy with each of those, and more happy than with the combinations on the lower indifference curve. But is it the highest one she can get to? No. She should keep going until she can get to the highest indifference curve she can. The last indifference curve that is just touching the budget line, before it flies off the budget line and becomes unaffordable. And so this is the highest indifference curve we can get to while we're still touching the budget line. And because of the shape of this, see, this is why it's sneaky, because of the shape of this indifference curve, it will have one point that just touches the budget line. Obviously that combination is even more preferred, but it's beyond the budget line, it's not affordable. That's the indifference curve that she will settle on, and she will choose this point because this is the only combination for this highest indifference curve she can get to that she can afford. That's 2 bags of nuts and 3 smoothies. So that's the combination that a rational Jenny will choose. Now let's change the price of smoothies. Let's increase the price from $2 to $3. and we'll say the nuts stay the same price. How has Jenny's budget line changed? What combination will she now choose? Alright, so here's where we were originally, and as part of constructing this budget line, remember, we noted that the price of smoothies was $2. But now the price of smoothies has gone up to $3, so we need to recalculate the maximum number of smoothies you could possibly buy, which will alter the budget line. So we just calculate it again. Budget divided by the price of smoothies, $12 divided by the new price, which is $3. So the maximum number of smoothies that Jenny could purchase now at that higher price of smoothies is 4 smoothies here. So we'd have to swivel the budget line inwards to reflect that higher price. Alright, which combination will she choose now? The highest indifference curve she can get to on the new budget line, which is here. Okay, so what's slightly interesting about this is that the quantity of nuts that she has chosen doesn't change, but the quantity of smoothies has decreased. So at the higher price of $3, now a rational Jenny will choose 2 smoothies. Now we have all the data we need to derive Jenny's demand curve for smoothies. Hooray! There's the curve we originally constructed. Now we're going to use the information here to construct a demand curve. Now you remember that when the price of smoothies was $2, Jenny chose 3 smoothies. And we just figured out that when the price of smoothies increased to $3, she chose 2 smoothies instead. She demanded 2. So, join the dots. Voila, we've got a little notional demand curve for Jenny's demand curve for smoothies. And that is that.